All right. Hey, everybody. My name is Will, and I'm so excited to get to talk with you all today about Jetpack Compose. I want to start with a bit of a story. It's a story that I think at least some of you may relate to if you've started using Compose yet. If you don't relate to it yet, maybe you will sometime soon. My story started on May 18th when Google announced that in July, Jetpack Compose would reach 1.0 stable, production ready. Fantastic. Now, we're all mature, responsible developers here. We'd never use anything before Google announced that it was production ready, right? Yeah, sure, absolutely. But our team had been looking at Compose for a while, hunting for any excuse to try it out in the app. And the 1.0 release happened to coincide perfectly with a UI refresh that our awesome design team came up with, a UI refresh that relied heavily on standardized components utilized throughout the application, combined together in consistent ways. It was like it was meant to be. So we started with a few code labs, kind of like the one we did earlier today. I think we actually did that same one. We ran through them as a team. We talked about Compose. We came up with a few standards, and then we assigned one of our senior engineers to convert one of our out of the way screens. We have a list of languages that you can select to change the app to use a different translation. It's a pretty straightforward recycler view. You select an item. The team figured it'd probably be a perfect trial and training ground for our team to figure out how Compose works. So one of our engineers set out, he got a prototype together, we did a group code review, we marveled at the beauty of a lazy column and lamented all the brain cells that we'd lost on diffutils and view holders and super complicated notify item inserted code, which is now like almost free. So we merged it in. I grabbed the branch, I went to the settings page, and I clicked on the link to the screen that was now in Compose, and nothing happened. So I waited for about a second. I wondered, did I not touch up in the right place? Did I click it wrong? When it finally loaded, almost 2 seconds after I clicked the link. Now, I kind of wondered, did I do something wrong? So I closed out the application and I tried it again. Same result. I remember sitting here thinking, there's no way we can ship this. This is the simplest screen in our app. 2 seconds to render? No way. The performance gap is just too huge. So that day, my team and I embarked on a journey to figure out what it would take to get this to the point where it was usable, not just on flagship Pixels and Galaxy phones, but on all of the terrible devices that our worst contributor devices use. So fast forward to 4 months later, and now all of our main app experience is written in Jetpack Compose. Every new feature we write is 100% Compose. We're super happy with the performance, even on low-end devices. So today, I want to talk you through how we got there, where we are, where this performance gap comes from, how we brought it down, and the things our team learned about performance, both with Jetpack Compose and with the Android compiler itself along the way. We'll cover a few beginner level simple tips and tricks to get things started and to get them into a usable place. Then we'll talk a little bit about some of the more advanced aspects of Compose for people who are looking to push things even further. To start, we need to understand what sort of time we're working with when we talk about render time in Jetpack Compose. So let's start with a little bit of data. So the first thing to understand when you measure something is what exactly you need to measure. In Android, when an activity or fragment is loaded, a few things happen. First, we have the activity or fragment lifecycle. This is what we're familiar with on create, on start, on resume, or if you're using a fragment, on create, on start, resume, and about 20 other methods sprinkled in between. And then, after on resume, two things happen. First, the screen calculates its initial frame, and second, it draws it onto the screen. This is a lot of stuff that needs to happen, and while it happens, the user has to wait. So how long it takes matters a lot, especially if the user has just tapped something. People expect things to happen fast. So, to figure out the timing, my team and I put together a custom logging system that gave us the system time at various points in the cycle in a way that was performant, wouldn't impact the performance itself, so we could figure out how things were impacted. We also pulled out 5 test phones across various brands and versions of Android, so the results would be easier to see trends and make sure that, one device with weird render times didn't mess up our data. So we had two kind of scenarios that we focused on. One that was pure XML, recycler view with view holders, and one that was pure compose. So at the root of the activity, that was the only activity in this application, we used the set content method. And what we found was this. On average, pure XML took around half a second, an average of 345 milliseconds to render. In contrast, the composable version of the screen took an average of right around a second and a half, 1,418 milliseconds to render. I got to admit, this was not the result that I wanted. Compose felt slow on my test device, but it was the slowest device that I had. I was kind of hoping it was all in my head. And then it was like, maybe what I should do is go into my XML, replace the recycler view with an old-fashioned list view, and then wrap it in nested relative layouts until Compose comes out on top. But it's better to be honest with our data than to just pick and choose the data that we like. So instead, I scoured the internet for any clues for how we could speed things up. And one of the first things that I found was comments online that both debuggability and R8 obfuscation were supposed to make things faster. But make things faster is a relatively vague term. On the slowest devices we're looking at, the difference was almost 2,000 milliseconds versus 400 milliseconds. So does it cut 50 milliseconds off? Does it cut 100 milliseconds off? 1,000? 1,200? Well, fortunately, we had our sample project ready to go. So here's what we tested. Pure XML, again, set with a recycler view, with view holders, pure compose with a lazy column, compose with the debug flag disabled but with R8 off, and then compose with the debug flag disabled and R8 enabled. Here's what we found. First, let's look at what happened when we disabled debuggability. As you can see, pretty good first step. Compose views with debuggability disabled took an average of 810 milliseconds. So by using a release build instead of a debug build, it takes a pretty significant step. How about with R8? Well, more good news here. Adding R8 to the mix cut things down even further. At this point, we've moved to an average of 574 milliseconds across our devices. It's still almost 60% slower than XML, but that's a far cry from what we're seeing on local debug builds, which stand more than 3 times slower. So this brings us to the first guidelines that we set up on our team in order to produce speedy composables. Make sure that your R8 is configured in such a way that all composable code, if possible, is being minified. I don't know if many of you made it to Jitin's awesome talk earlier. He walked through minification. If you haven't had a chance, you can check it later. He talks through how to make sure that this is set up correctly, and it's really important that we do so. Interestingly, I was listening to an episode of Android Developers Backstage podcast a few weeks ago where members of the Compose team were talking about this very issue. Somebody asked the question, does R8 have special considerations for Compose? And their answer was, no, it actually doesn't. It's just that the things that Compose does to make life easier for developers are things that R8 is very good at speeding up. So under the hood, Compose relies super heavily on lambdas. Apparently, lambdas are one of the things that R8 improves the most. And that's why we have such a drastic impact here. So, got our composable build. Now we need to figure out the right way to integrate it. As our team was discussing how we integrate composables into our existing application, we came up with 3 kind of strategies that we needed to decide between. The first is to convert entire screens one at a time and make like fragments or activities fully composed with set content. The next one is to convert sections of the composable as blocks so that we have a single compose view near the root of our XML, but with XML around it. And the third one is to convert piece by piece. So for example, we'd convert our recycler view cells, but keep the recycler view in XML and have many small composables replacing the pieces of the content. So fortunately, we already have our sample project set up. So we ran the configurations and here's what we found. For Compose straight up, it was relatively fast, kind of similar to what we saw before. it turns out having many composables within your XML was actually a lot slower than having a single composable. This chart actually had us rethink our strategy for converting our main experience. Previously, we'd been working on converting one element at a time. Instead, we decided to take the plunge and go ahead and convert most of our main experience at one time into a single compose view. So this brings us to our second performance guideline. In compose testing, more compose views increase the amount of time that it took things to render. But while we were testing this process, we noticed something else. It was interesting to note that actually a warm start and a cold start took a different amount of time. So we devised another test. What happens if we put compose on the second page of our app instead of the first? So in our test app, we came up with this intermediary activity that we would then navigate to our primary composable activity. So what happens then is does the screen render faster? And the answer was, yeah, it actually made a difference. So you can see in this chart, we actually had two different intermediary screens, one that had another compose view on it and one that did not have another compose view on it. So if the intermediary screen did not have compose, it took the time down by about 200 milliseconds. If the intermediary screen had compose, it actually took the time down by another 200 milliseconds. Now, for this device, this places the rendering of subsequent screens with compose at about 422 milliseconds, which brings us to the point where for these subsequent screens, compose is actually within about 20% of the render time for XML. Now we still have to pay that cost at some point. So it turns out what's happening here is, from the Android Studio profiler, we could kind of see that what's happening is the first time you initialize a compose, the composition engine needs to be created, and it has a measurable impact on the time. So you have to create it sooner or later. But think back to my first experience with Compose. It was a little bit extra frustrating because I just tapped a button, and I kind of expected that to happen quickly. What if we moved that to our splash screen or our app launch? We want those components to be as fast as possible, but they're not happening as a response to an immediate user request. So in our case, we were actually able to find a place where we could render our first composable while we were initializing some of our third-party libraries. Thus, not only moving that cost away from a place where a user was trying to switch tabs or press a button, but actually kind of removing it entirely because we had other initialization happening at the same time. So this brings us to our third lesson. For performance, the first composable that you render is slower than subsequent composables. So try to move it away from the screens where you need to render the most quickly. And whatever you do, don't put it within a recycler view, because then you'll be scrolling down and you'll suddenly get a ton of jank. All right. In order to understand this next point, I actually want to take a second to talk about state in composables. So have a look at this block of sample code. So here we have within a view model a function to set data to a list of data. It sets the state value. So in this case, this is what it would look like if a state is a composable flow. I'm sorry, a coroutine flow. And then here we collect the flow as a state. And whenever we're rendering our composable, we display a lazy column, we take the items, we sort them, and then we display each of the items. This code is actually super laggy. And does anybody see why? I'll see. I'll give you a second to think about it. But okay, so I'll talk about it. The thing to know about your composable methods is that they can actually fire a lot. So this is the method that determines essentially what your UI should look like. And anytime anything about your UI changes, there is a chance that your composition will be executed again, and this method will call again. Now, computers are fast. They're faster than we think they are. So normally walking through a chain like this and building a picture of what kinds of views you're using should be extremely fast. But say you do something like sorting a list or reading from shared preferences or mapping values to other values or some other calculation as part of your composition. You'll almost definitely see it in the performance of a view. In this example, we're so used to having our list modification functions, our sort function here, as a part of our code that we use that's available to us at all times, that we're just kind of sorting our list here within the composition, but that has a cost. And if that cost happens while we're animating, that animation will be jumpier. Our renders may be slower, and perhaps more importantly, if our view is scrollable, it'll be janky as the user is scrolling through it. So what do we do instead? Well, at Premise, we always tend to have as much of our data in view models as possible, which expose their state as a single calculated state object. Any calculation that's more complicated than an if statement should happen within the view model, like this slide. So you can see here, we're sorting the data when it's set rather than sorting it down here within the composable scope. Um, This has a few benefits. Not only do we have some great unit testing utilities that make it really easy for us to quickly test our view models, it also makes changing our view layer very simple. In fact, we've had some cases where we've converted from XML to Compose with only extremely superficial changes to our view models, but perhaps most importantly here, it doesn't perform business logic when the composition needs to be recreated. There's another solution here as well, and I actually want to talk about it a little bit because it gives us an interesting look into how Compose handles composition under the hood, and that is the remember block. Have a look at this page here. So what happens here is that the sorting happens within the remember block, and then the value of that remember block is used below. So you can use it like it's a normal variable. You can iterate over it, you can interact with it, you can even set it, assuming that you created it using the mutable state of. But when your composition is compiled, a few interesting things happen under the hood by the compiler. The first is that the variable that the remember creates, in this case item list, isn't actually a list of items. It actually becomes a state object wrapping the list of items, just like the one that you get from exposing your coroutine flow or live data or RX flowable as state. So any read fetches the value that was previously calculated. If you created a mutable state in the remember, any write updates that value and then tells any compositions that rely on it to also update. In this case, we're using derived state of, in which the composition actually tracks the state or the flow that is passed into it, and anytime it changes, performs the calculation and calls for the recomposition only if those results have changed. Using this feature, Compose lets us easily memoize our variables that require business logic so we can make their updates as simple and fast as possible. So whenever this view is recomposed, it doesn't replace this state with a previous one. It compares the data class to its previous value and then only updates the comparison if the value has changed. So let's give an example to talk about what this looks like practically. Let's say we have a list of 5 items here. They're random, numbered 1 through 5, but unsorted. We set it, it performs the calculation, it sorts them. Then we need to recompose 20 times because there's an animation occurring. There's 20 different frames in this animation, but our unsorted list hasn't changed. In this case, the sorting function would not be called because the list was actually the same as the first time we remembered that value, and our lazy column below also will probably not be recomposed unless there are other things causing its recomposition because of the way that the remembered state object is its only data source. Now let's imagine we updated the list, but we still had the numbers 1 through 5, just scrambled in a different order. In this case, the sorted list is actually the same as it was before. So while we'll do the sorting again, we won't recompile all of our views because, again, the data hasn't changed. Then let's say we add a bunch of new values. So our input list is now 10 items long. Only then will our sorting fire again and our list below be recomposed. Well, personally, I still definitely prefer to keep as much state as possible outside of the view layer. If you have a state that needs to be in your view layer, understanding how remember and view states work can give you the edge on making sure that you're doing recomposition in a way that's fast and as simple as possible. So tip number 4 is use state, and remember to minimize the calculation within your composables. So this is great at limiting the number of recompositions that we need to happen, but sometimes, honestly, there's no way around it for complicated views. We've seen some awesome UI that happens on Android. Sometimes there's just a lot going on, and recomposition needs to occur on larger objects with a lot of calculation. This is especially true when elements move. Now, Compose under the hood is very smart, but it does not always know how to handle the reordering of elements. And as a result, you could end up performing more recomposition than you expect. Fortunately, Compose has a system for that as well. Those of us who have spent time with Recycler View and the performance pros and cons are probably familiar with diffutil. Diffutil is a system that works with Recycler View to speed up the refreshing of data. It has two methods, one that checks if the item is the same as a previously rendered item, and one that measures if the item has changed. So the first one will hunt through a Recycler View's content to find out if the element present already exists, and the second one identifies if that existing element needs to be redrawn. Lazy columns actually have something kind of like this as well. It's an optional parameter, but if you look at each of the items in lazy columns and list, you have the ability to pass a key lambda in. This key works kind of like diffutil methods for identifying if the object is the same. So as long as you pass in a serializable object here, moving this element around and reordering it will not cause it and the elements between it to be recomposed, whereas missing it could not only cause the tagged view to recompose, but possibly the views around it as well. This can be really important in dynamic UI. Compose is great at appending items to the end of the list, but if an element is inserted into the middle of a composition, there's a chance that most of the elements after it will recompose, even if they haven't changed. Adding a stable key like this helps Compose understand the composition already contains this element, so just move it. But note that these keys do need to be unique or you'll get a crash. Leland Richardson has a really awesome blog post about it. So there's another cool thing about this. See, we're used to keys and data states and things like that being an aspect of Recycler View, but if our composition contains movable elements that are outside of our lazy columns, that doesn't necessarily help us. Fortunately, Compose offers a key composable that gives us this same behavior everywhere. Here's kind of a simplistic example of what this might look like. Let's imagine that we have an offline banner that could appear in a couple of different places, and then of course we have our primary content. If this is the case, using keys like this allows us to move these pieces around in such a way that doesn't require nearly as much recomposition, because of course, recomposition is one of the most expensive parts of this experience. So using these keys will allow us to be more intentional with moving pieces around and limiting our recomposition as much as possible. Shout out to Jorge Castillo, whose awesome book, Jetpack Compose Internals, has some great information about this and tons of other content. It's been mentioned a few times in other talks today. It's actually free on LeanPub right now. Highly recommend checking it out. So at this point, I want to step back a bit and look at things from another point of view. Oh, real quickly, number 5, use keys to allow recompositions to reorder and limit costly recomposition. So let's step back and look at things from another point of view. See, we've covered some practical tips today about the day-to-day work of normal developers. This should be enough for 95% of our experiences. And at this point, for most of us, the performance gap we talked about at the start has moved from around 300% worse to really within about 20% of each other. Considering how much easier it is to write performant UI in Compose in most cases, in fact, I'd say probably in everyone's case, this is as far as we need to go. There's no notify dataset changed on lazy column. You can't accidentally write nested constraint layouts in Compose. It's way less a problem than writing complicated recycler views. But can we go just a little bit farther? So there's something interesting about Compose. This was actually discussed in, let's see, it was the talk earlier today about what's the word I'm looking for? annotation processing. Compose isn't shipped with core Android OS or Google Play services. It's shipped as a library. This has a really great impact of being backwards compatible with much older devices and being available on devices that don't have Play services installed. This is a really important benefit. We all know how slow Android users are to adopt to new operating systems. Most phones only get a few years of upgrade. And yet, now, 4 months after Compose hit 1.0, right around 95% of Android devices in the wild can use apps built with Jetpack Compose. And let's face it, if you're supporting KitKat or older, you're probably already familiar with the host of libraries that aren't available to you. For comparison, the iOS equivalent, SwiftUI, has been released for more than 2 years. And according to the research that I was finding, it's a little difficult to find exact numbers, but it still has almost 10% of the market share for which it isn't available. However, including Compose as a library like this has one big downside for performance. And to understand it, we're going to go back in time a bit and understand a little bit more about how Android uses the code that we build for it. So let's step into a time machine. The year is 2009. Barack Obama just started his first term as president of the United States. Bitcoin was just created at the shocking price of slightly less than a cent, and Dalvik, the first Android Java engine, has entered the scene. Now, the thing about Dalvik is that it tried to keep the bytecode of the applications that you build as small as possible. My first Android phone, the LG Optimus S, had 140 megabytes of memory. It's 140 megabytes of memory. Nowadays, I'm not even sure if a Hello World app would fit onto it. The way that it kept size down was by using a just-in-time compilation system. So whenever you installed an APK, it only had Java bytecode, not machine code, which is faster but larger. Whenever you needed a class, it was compiled at runtime from bytecode into machine code. So this meant that both the storage and the memory footprint were smaller. But anytime you needed to load a new class, it took some time. Smartphones were new enough, applications were simple enough that the trade-off of memory usage for loading speed was totally worth it. But then, in 2016, Art entered the scene. Tested in KitKat but made standard in API 21 or Android 5, Art, or Android Runtime, replaced Dalvik's just-in-time compilation with ahead-of-time compilation. Your application was still delivered in bytecode, but whenever it made its way onto the device, the whole application was installed as machine code, meaning that apps ran faster at the cost of higher memory usage and longer installation time. But the world now has much larger phones. In the era of the Optimus was over. Now we were seeing phones like my Galaxy S5 with its 16 gigabytes of internal memory. I remember thinking I would never fill that up. Oh, youth. Anyway, so Android moved from just in time to ahead of time until Android 7. In Android 7, a new hybrid approach was introduced. Now, what happens is that the most frequently used code, described as hot code, will be precompiled, taking up more memory, whereas the code you don't use as often will be compiled just in time. Also, if you frequently just in time compile the same block of code, what the system does is it's smart and it keeps that code around. Or even better, what if the system kept it around and then reported back to the Play Store that these were the pieces that you use frequently, so that next time someone downloads your app, they go ahead and pre-compile those blocks so it loads faster the first time. That's exactly what Google does. If you have an alpha or beta group, or even just roll out slowly over time, the Play Store will identify blocks of code called profiles that need to be just in time compiled the most often and sends those profiles when the application is installed, so that some sections of your application, like your launch screen, your new user experience, or your home screen, will be pre-compiled whenever your application is idle after install and will load faster, while that one obscure about page that your analytics says 4 people have even gone to in the last 5 years will just take a little bit longer to load. So this matters for us when we're talking about Compose, because Compose is a library included in our application. And on first launch, even if we're using the release versions of our apps, we won't have these profiles pre-compiled for us. The good news is that in the wild, if a user has installed the app from the Play Store, it will come with these profiles for our most commonly used classes that'll help them render faster once the ahead of time compilation is complete. Fortunately, There's tooling that'll help us figure out how much of an impact that this just-in-time compilation will have on our applications. In recent versions of Android, we can run profiling in a way that doesn't impact our performance, like the Android Studio profiler, who I love, but it crawls your application to a halt. You can enable it from the developer options menu. We can grab those system traces from our device and upload them to a website called perfetto.dev. It's an awesome tool that will take these traces from your device and render them visually. We can see them here. This was a render from actually that slow device that I keep talking about. Great for testing. You can see how long it took to draw different various blocks of code. So you can see here, there's the activity start. Here's the choreographer. You can see where it does measurements, and you can see where it does draw. But if you scroll down a little bit, you can see another section in Perfetto. So you see here, we have a JIT thread pool. And if you highlight it, it'll tell you these are the classes that compiled, and this is how long it took. So in this case, my initialization was about 750 milliseconds processing, and the amount of time spent JIT compiling Compose methods was around 140 milliseconds, which is good news. This means that for users who install the app from the Play Store on the device, assuming the phone has time to install the profiles, which is pretty likely, the initial render time should be down to 600 milliseconds. In my experience, that's actually pretty close to pure XML. There's one last thing to say about profiles. Let's say you aren't running through the Play Store, but you need your first experience to be faster, or for some reason there's something that isn't automatically identified as a profile, but you want to have it anyway because it's a part of some critical flow, even if it's in a side flow. The Compose team actually shipped a tool called Profile Installer that will let you tell the system which profiles you want. In almost all cases, the right course here is probably to release to Play Store and let Google take care of this for you. But if you want to force it, you can use the Android Profiler tool. This is a tool that you can ship with your application that tells Android what code needs to be compiled ahead of time when the application is installed. It actually kind of works like ProGuard. You include a file with a list of flags indicating what profiles need to be hot, startup, or post-startup. You name it baseline prof.txt and place it in the root of your module or directory. You can find these instructions within the Profile Installer Jetpack library. But it's kind of intentionally difficult to use, I think. And I think it's because Google kind of wants to kind of lead people away from it if you need to. And when I ran it on my test application, including profiles for the entirety of Compose, I noticed that my render time cut down to 565 milliseconds. That actually matches about what we would have expected from these two slides. It was about 700 with about 150 milliseconds of JIT compiling. So this brought my render time to 565 milliseconds, which is less than 10% slower than XML. And if the composer didn't need to be created, I actually suspect that in most cases where this was on user devices, Compose might even be faster than XML. So there you have it. There's a little bit of information about Profile Installer. Here are the guidelines for faster composable renders, ending with, of course, understanding how JIT compilation will impact your initial and subsequent renders. So in summary, is your composition running slow? Run the profiler. Is it performing calculations on recomposition? Move that logic to a remember function or to your view models. Is the recomposition itself taking a while? Make sure that R8 is applied correctly. Cut down on the XML and other tangential pieces, and look for unnecessary recomposition that can be solved by tagging composables. Still not enough? Check to see if you're JIT compiling a lot of Compose code. You might be able to include a few profiles that'll help speed up your launch, or at very least have more confidence in the experience that your users will get when installing from the Play Store. We've been using Compose for a few months now, and our team is so happy with it. Our developers love it. Our design team is happy that the designs that they have are so much more scalable. Reuse is super easy. Being able to write custom views in minutes is a dream come true. And the minor performance downsides are totally offset by the fact that it's so much harder to do things wrong. The documentation is amazing. This isn't even getting into the incredible modifier system that makes it so easy to do cool things. Let me tell you guys, I've written custom nested scrolling behavior in both XML and Compose. It is insane how much easier it is to write using modifiers. I surveyed our team. Everyone said Compose is our preferred way of writing UI. And I hope these tricks and tips help you all get to the same place where you're writing fast, stable, and awesome composable code. And of course, if anyone wants to continue the conversation, please feel free to hit me up on LinkedIn or Twitter or email. I also try to hang out in the Kotlin Lang Slack, where there's great discussions in the Composable channel. And thank you for listening. We've covered a ton of grounds today. Let's go for questions and answers. Shalom. Let's see if we've got any questions.
It seems like I'm the only one who's written some so far. So if you want to start with mine, you can. Or if you want to give people another minute, you can. Gabor, looking for you. Come on, wake up.
Let's start with yours. Let's see. Do we have one selected yet? I can't see it. Let's see.
Oh,
no. Stop presenting.
Do you want me to just select them and then show? And then
go for it.
Yeah, cool. Let's go with the first one.
Are there Compose optimizations in the Compose team's pipeline that could result in different performance results that you have seen? Yeah, this is a really great question. I think that the answer is yes, but I don't think that they have made them really clear what they are. So after we published this talk kind of came out of a blog post that we wrote a couple months ago. And after we did, Leland Richardson, one of the heads of the Compose team, took some time to sit down with me and another engineer on our team just to kind of talk through it. He had some really, really excellent thoughts and explanations as to what we were finding, as well as some other tips for how we could take it a little bit further, which is, by the way, how we ended up diving into Profile Installer, at least to understand what kind of impact that had on our system. In it, he talked about how particularly, obviously JIT compilation is something that they're continuing to work on. I wonder if we won't see kind of the JIT profiles for Compose be included in future versions of Android. I'm sure that they're continuing to kind of think through something like that. That's purely hypothetical. But I know that in their minds, performance of lazy columns and rows was something that he kind of mentioned they were thinking about. And just in general, I think the performance that they have today is 100% adequate. Like I said, our team is super happy with the performance that we've seen. I suspect that it'll continue to improve over time. Yeah, great question. Does state hoisting improve Compose performance? Yeah, that's a really good question. I'm gonna say probably. Yeah, probably. Let's see. So give me just a second. I'm going to. So I personally, and this is kind of what I was talking about when recommending that we move all business logic, or at least as much business logic as possible, out of our composable. So state hoisting is the pattern of moving state into the caller to try and make the composable stateless. What happens, in my understanding, so I'm going to be thinking about things that I've read, but ultimately this is a really good question. Please feel free to double check all of it. I believe that when you have all of your state hoisted, Compose is able to better understand what elements need to be re-rendered every time the state changes. But figuring out what's going to be recomposed is kind of a complicated thing. So I found that sometimes you put breakpoints and sometimes unexpected things are being recomposed. There's not a ton of visibility today into what goes into recomposition, but I suspect that state hoisting will help some in identifying that. Yeah, great question. And if I didn't answer that question to satisfaction, post about it in chat and I can discuss it further. Is it possible to share the XML layout and compose? Yes, absolutely. I will, let me see. I don't think I have it in a public place right now. It's a really, really simple XML. In fact, I can, let's see. I will see if I can do that shortly, and we'll try and get it uploaded someplace. Yeah, really good question, Jason. Yep. If you would develop a new app, would Compose be the preference? So here's the thing. This is a really good question. It's one that I've thought about a lot because it's something that's come up. Like, should you use Compose or XML? I will tell you, I believe, and I think that the comparison of Kotlin to Java, of Compose to XML, is actually a perfect comparison. I believe that 5 years from now, the majority of applications will be written with Compose. And also, I believe that there will be a few people who hold out to XML forever. And I also think that if you are writing with a legacy application, you'll always need to know XML. So, it's the same for Java. Like, if I were writing a new application today, if I were learning how to kind of do the best way to do Android, I'd probably try an application that was 100% Kotlin, 100% Compose. But if you want to get a job at a big company, you're probably going to need to know both. In fact, I'd probably say today, if you want to get a job at a big company, if the company isn't Premise Data, which is where I work, probably you're going to be doing almost all of your work in XML. We are hiring, by the way, for senior developers, but yeah, it's a really good question. I will also say this: I grade a lot of sample projects, and I haven't seen any written in Compose yet. If I did see one written in Compose, it would probably be pretty interesting to me. Does that answer that question, John? That's a really good question. XML forever. Tags make us strong. Todd, no, you're killing me. For all the performance testing, was it all on one local machine across all dev machines, or did it include production devices? So this is a really good question. And this is kind of asking the question of, is there the possibility that the data was incorrect or was miscalculated? This is 100% a good question. The building was on my local machine, the one that I'm talking to you from right now. The testing was on, let's see if I can find them. I have one device. I've got a bunch of other devices. I'll tell you, actually, when I wanted to test this, there's a store in the United States called Target that is kind of a general like store with a lot of different stuff. I walked down to a Target that's right next to our Seattle office, and I said, guys, I want you to give me the worst phone that you have in your store. And they kind of looked at me funny, and they were like, okay, do you want to plan with that? It's like, no. I want a burner phone, and I want the phone that you get the most complaints about. And they ended up bringing me like 3 or 4 devices, and I was like, great, I'll buy all of them. They were like $10 each. I think that they were more like 20 or 30, but super cheap devices, really, really terrible. Those were great for measuring performance because it is less likely for little variations caused by things like something else going on in the background to impact it so severely. But I did test across a bunch of devices. If you actually search for my blog post, I have the full matrix of data that I have included there. I also measured each of them a couple times. But it is true that it was all from a single local machine. It was my MacBook Pro. It's a great question. Yeah. Did I answer that question? If I missed anything, please feel free to post it into the chat. Or maybe, I don't know what we were thinking we'd do after this. Maybe I can jump to a table and we can maybe chat about that a little bit further. So it's a really, really good thing to think about. Have to use lambdas comes nested lambdas that are difficult to read. Static code analysis tool. This is a really good question. We use detect, DETEKT for this. We actually, one of the guys who works with us, his name is Nate Abel, and he actually does a bunch of talks about using Danger, which is a utility that will automatically comment on GitHub pull requests. And this is actually one of the comments that it gives us. So if you have things that are nested too deeply, it will actually yell at you not to nest things quite so deeply. We use Detect for that. Detect is pretty cool. I like it a lot. We've kind of played around with the rules pretty significantly. Typically, the way that we use Compose at Premise is we have a lot of base composables that have no reference to the rest of the application. We actually have those in a separate module. So if we have, for example, a banner, we won't have an offline banner. Well, we will, but like we'll have a banner composable that will exist in our design module that matches kind of what our design team came up with. And then in our application, like in specific use cases, we'll have like a share banner or offline banner or something like that, like the specific use cases that we're dealing with that have the business logic themselves. And as a result of having that kind of strategy, it's pretty rare for us to get very deep when it comes to our composable lambdas. I think usually the deepest that it'll get will be kind of a root view, and then maybe one or two layers for example, like a lazy column, and then with its lazy column, like an item. I think if it's going to go much deeper than that, you're probably going to get a comment to like split out these composables. A really nice thing about splitting out composables is it makes it much easier to put preview annotations on it and preview just a single composable, which actually brings us back to hoisted state. It's a whole lot easier to preview a hoisted composable because of the fact that it doesn't have all these other kind of objects that you need to initialize, particularly hoisting it with something as close to primitives as possible. And so we tend to have extensive previews in our library. We kind of use that almost like unit testing your composable code. Of course, you can unit test composable using Android tests, but having these previews for each of our kind of shared composables that are sort of the root of our design foundation kind of lets us keep an eye on real time if the changes that we're making break anything. Yeah, great question. Yeah. Let's see. Any other questions? What were the burner phones? Yeah. Let's see. One of them was, gosh, I wish I had them here. Hold on. I can actually look that up. By the way, I always keep an eye on, again, probably mostly for US focused people because these deals are mostly like US focused. I always keep an eye on Slick Deals, the website, for kind of terrible Android phones that are coming up. And so in this case, there was a Blue View 2. So BLU is bold like us. Those phones are great test phones. They're terrible. Terrible is kind of a bad way of saying it. They do all kinds of weird stuff. When I worked at OfferUp before working at Premise, we had blue phones that would just always render things weirdly. There was an LG Journey, and I think there was a Moto G. It was one of the old Moto G phones. So I actually think on Slick Deals right now, there's a deal for $25 for a Moto G and 1 year of service with, of course, extremely limited service with it. Yeah, it was a really, really good one. Really good one. Yep. Moto G. Absolutely. Moto G. Truly, it's I will tell you as a side note, I'm kind of like my kids love Mario Kart Tour, and they recently upgraded it so that it doesn't work with a bunch of other devices. So I've got my eyes open for a new phone, and Moto G doesn't work with it either. I'm gonna have to get them a solidly mediocre phone, whereas these terrible phones that I've been getting them don't do it anymore. So we'll keep my eyes open. Yeah. Yeah. Do you have to spend a lot of effort making composable previews? Yeah, this is a really good question. Previews are a really interesting tool. I like previews a lot because they give you the ability to kind of see how things work beforehand. Usually for us, the views in the composable library we spend effort on making composable previews. And that's just because they're, again, they're the foundation of the rest of our project. It's really, really important that if we're changing a composable, like moving something to a variable or something like that, we don't impact the other places where we're using the composables. Library of previews. I'm not 100% sure what you mean by that phrase, Jason. That's a really good question. If what I think you're talking about is we actually, then this may or may not answer this question. We put together a separate application, like a separate application configuration that is our composable preview. The idea of it is if our designers want to see how our composables work, they can actually download this other application. It's got a bunch of samples. They have one that they click for buttons, one they click for text, one for banners, all of the things that they kind of see as our standard design library, all of our colors and spacing and things like that. They can install it to a physical device and see how it looks. I don't know if that's what you're talking about, but if it is, yes, we have that. If not, we have some previews. I really like previews if, in our main app module, I'll usually put together a preview if I have a standalone piece of content or if I have something that's not rendering in the way that I expect after maybe 1 or 2 render passes. You're always going to have little things like, for example, the order of the other day, I was having issues with an image where the order of modifiers was making it so that the spacing was making the size of the image smaller. And I couldn't figure out why this composable icon wasn't showing up. So I went ahead and rendered it as a preview. I could see a little bit more about like what was happening. Okay, it's there in the view, but it's just that there's nothing. Okay, well, maybe I should reorder these. Oh yeah, there we go. Perfect. Now I'm not closing in my image. I'm moving the spacing to be on the outside of the image. So yeah, that's kind of my thought about preview, but it's a really good question. If I'm seeing this correctly, I think that's it for our questions. Yeah, great questions, team. Really, really good thoughts. Thank you guys for listening. I'm super excited about Jetpack Compose. I hope you all are too.
Okay, so we're going to edit this recording. We're going to frame it so that Will is advocating for XML, as Todd recognized he is advocating for. And that's how this will be. Yeah, long live XML. Thank you, Jason.
This is step 1 for how to get speakers not to come back to your event. I'm kidding. No. I think if anybody saw me advocating for XML over Compose and then Googled my name, they might be a little bit surprised.
Yeah, Will's very confused, clearly.
I'm very confused. It's all that Compose. That really is what made me so confused.
Yeah, you got to get more composure, all right?
I gotta work on it.
Alrighty, guys. Well, that's the end for today. I'm gonna hang out, whoever wants, at the tables for a little longer. And yeah, thank you, Will, for closing us out. It's been a wonderful day.
Yeah, it has. Man, there have been some great talks today.
Yeah, we've been very fortunate. Alrighty, guys. See you at the tables.
See you at the tables.